Okay, so today we're going to take a look at completing the square, which completing the square is the first method that is guaranteed to always work. Factoring is not always possible. Sometimes you will have quadratics that it's just not possible for us to factor because you're looking for fractions, and fractions are harder for us to deal with. So the last two methods we're going to go over for solving quadratics, completing the square, and then obviously the quadratic formula will be the last thing, are methods that are guaranteed to work. So today we're going to take a look at completing the square. Fair warning, completing the square can be confusing. I'll go through, give as much detail as possible, give you the steps on what you're going to do, and we'll run through a whole bunch of examples. But compared to previous things that we've done so far, like completing the square is, in this unit, one of the most confusing and probably the most confusing thing we'll do. So we're going to start with not completing the square, but what happens when you don't have a b value. So previously we've always had an a and a b value, and then from there you would factor. So let's say we have something like ax squared is equal to c, or ax squared plus c is equal to a number. What I can do is, because you just have an x squared term, you can easily isolate that and then solve. So when we have this example of 3x squared plus 5 is equal to 20, what I can do is I can isolate this x squared and then take the square root of both sides. So we're going to go ahead and isolate that x squared by subtracting 5. You get 3x squared is equal to 15. Divide by 3. You get x squared is equal to 5. And then to get rid of the squared term, you would take the square root of both sides, and you get x is equal to a positive or a negative square root of 5. So now I put the positive and negative square root of 5 because when we take a square root, traditionally we have focused on the positive number only, but there is a second negative variation that also works. So the square root of 5 is going to be a decimal. It's approximately 2.24, I believe. So we have the square root of 5 is either positive 2.24 or negative 2.24. The reason why is that if you take 2.24 and square it, you would get 5, or approximately 5. If you take a negative 2.24 and square it, you would also get the same thing. So here's another example. We're going to do the same thing. I'm going to go ahead and isolate the x squared. So we're going to add 3 to both sides. You get 8x squared equals 32, so we'll divide by 8. We get x squared is equal to 4. Take the square root of both sides, and then x is equal to a positive or a negative 2. So a plus or minus 2. So do not forget the negative. You have a positive and negative answer because quadratics will have at most 2 x-intercepts. So it'd be a positive 2 and a negative 2. So now we get to completing the square. So we'll start with something very, very basic. What we're attempting to do with what is known as completing the square is make what is known as a perfect square trinomial. A perfect square trinomial is a trinomial, which means it has 3 terms, in which what I can do is I can take and factor this as x plus or minus some number, and we'll say that this is plus y squared is equal to some other number. So we're taking a trinomial, something that we've been factoring, and what happens is that you always end up with this x plus or minus some number squared, which is really easy to solve for. So the first thing we need to learn is, how do we make a perfect square trinomial? Well, the way that we're going to find a perfect square trinomial is we need to find out what this constant value needs to be. So I need to find the c value. So my c is always going to be equal to the b value divided by 2 squared. So we take the b value, divide by 2, square that. That's the number that I need for c to guarantee that this is a perfect square trinomial. So for my first example, 18 divided by 2, and then we're going to square that. So 18 divided by 2 gives you 9, which when you square gives you 81. So if you had x squared plus 18x plus 81, that is a perfect square trinomial. So now, hopefully, when you look at this, you immediately go, well, x squared plus 18x plus 81 is really easy to factor. Because what that would factor into would be x plus 9 squared. 9 plus 9 is 18. 9 times 9 is 81. And if you look, that value that we plugged into our parentheses comes from what number we squared, which if you realize that will be very beneficial for when we actually do completing the square. So here's another example. We're going to take our b value, which is a negative 24, divide that by 2, and then square it. So negative 24 divided by 2 gives you a negative 12, which then we square and gives us a positive 144, which means that my c value to be a perfect square trinomial would need to be 144. And then if you wanted to factor this, it would end up being x minus 12 squared. And then the last one, we're going to take our b value, divide by 2, and then square that. So 4 divided by 2 is 2. So you get 2 squared, which gives you 4. So my c value would be 4. And then if you were to factor that, it would just be x plus 2 squared. So if you want to find the c value, the constant value, you take your b, divide by 2, and square it. We will actually be using this when we complete the square. Okay, so steps on completing the square. So the first thing we always want to do in completing the square is making sure that we have an a value that's 1. It needs to be a case 1 quadratic. If it is not a case 1, you're going to divide everything by a, which can introduce some fractions. After we have that, we're going to isolate the constant, which means that we're going to take the c value, we're going to move it to the other side, because odds are this c value doesn't give me a perfect square trinomial. Then I'm going to find out what constant I need. So what we were just doing on the previous slide, we're going to find that constant, we're going to add it to both sides of the equation. Then I'm going to factor the trinomial. You'll take the square root of both sides, and then we'll finally solve for x. So here we have an example, x squared plus 6x minus 7. So the first thing I'm going to do is move this 7 to the other side of the equation, because this is not a perfect square trinomial. I cannot factor that as a perfect square, so we go ahead and move that over. So we get x squared plus 6x is equal to 7. So now I need to take my b value. So my c is going to be equal to b divided by 2 squared. So we have 6 divided by 2 squared, so we get 3 squared, which is 9. So my c value is going to be 9. So I need to add 9 to both sides of my equation. I have to add 9 to both sides of the equation because if I only add it on the left side, it's no longer a true equation. And I have altered it, so now I'm just going to go ahead and factor the trinomial. So on the left side, I have this x squared plus 6x plus 9. This is a perfect square trinomial, and it factors into x plus 3 squared. And then that's going to be equal to, on the right side, we have 7 plus 9, which gives me 16. So x plus 3 squared is equal to 16. I can take the square root of both sides. When you take the square root of the left side, what happens is that square just cancels out with the square root, and you have x plus 3 is equal to, on the right side, the square root of 16 is plus or minus 4. Then I'm going to go ahead and subtract 3 from both sides. So you get x is equal to negative 3 plus or minus 4. So now this plus or minus means that technically this splits into two separate equations. I have x is equal to negative 3 plus 4, and x is equal to negative 3 minus 4. So plus or minus. So x is equal to 1, and then you have x is equal to a negative 7. So my two solutions of this would be 1 and negative 7. So now if you looked at this, before we even did completing the square, this x squared plus 6x minus 7, it is not possible for you to factor that as... Actually, it is. It is possible to factor that as a case 1. Yeah, you would just factor this as a case 1, let's be honest. Much easier to do that. But this is an example of completing the square before we get to more complicated variations of this. So here's an example in which now I have an a value that is not 1. So what I need to do is I need to turn this into a case 1. So we're going to go ahead and divide everything by 2. And then we'll end up moving this c value to the other side. So you get x squared minus 5x. And then in this step, I'm just going to go ahead and move this negative 3 halves to the other side of my equation. So you would add that to both sides. So you get x squared minus 5x is equal to 3 halves. Now I need to find out what my c value needs to be. So we take a negative 5 divided by 2. And then we're going to square that. I'm going to leave this as a fraction because it's easier for me to deal with as a fraction. Because you get negative 5 times negative 5, which is a positive 25. 2 times 2 is 4, so I need to add 25 fourths to both sides of my equation. So you end up getting x squared minus 5x plus 25 fourths is equal to combine these, I need to make a common denominator. So we'll have 3 halves plus 25 fourths. Well, if I multiply the top and bottom of this by 2, you get 6 fourths. So 6 fourths plus 25 fourths would give you 31 fourths. Now I can go ahead and factor this perfect square trinomial on the left side, which it should factor into x minus 5 halves squared is equal to 31 fourths. So now that I've factored the left side, I can take the square root of both sides. When we take the square root of both sides of our equations, what's going to happen is the left side is x minus 5 halves. The right side, the square root of 31 is just going to be the square root of 31. There's nothing I can do. So plus or minus the square root of 31. This 4, the square root of 4 is 2. So I'm just going to write that as plus or minus the square root of 31 over 2. Then I'm going to go ahead and move this 5 halves to the other side. So we'll add 5 halves. So x is equal to 5 halves plus or minus the square root of 31 halves. Because I have a common denominator, we can just write this as one overall fraction. So x is equal to 5 plus or minus the square root of 31 over 2. I could go ahead and find out what this is, in which I would need to take the square root of 31. So let's take the square root of 31 and find out what that is. So the square root of 31, square root of 31 is approximately 5.6. So if I wanted to work this out and get a decimal answer, it's going to be 5 plus 5.6 divided by 2, and 5 minus 5.6 divided by 2. So 5 plus 5.6 gives you 10.6 divided by 2, which is going to be 5.3. And then over here, 5 minus 5.6 is a negative 0.6, which divided by 2 gives you a negative 0.3. So your two answers would be 5.3 or negative 0.3, or if you don't want to deal with decimals, that is a perfectly viable answer, is 5 plus or minus the square root of 31 divided by 2. And that is probably as complicated as you can really get with a completing the square, because we immediately introduced a whole bunch of fractions and we had to deal with said fractions. Here's another example in which this will kind of work out the same way as that last one that we just did. So we're going to divide everything by 5. So x squared minus 4/5 x, and then I'll go ahead and move this to the other side real fast, is equal to 2/5. So you're going to do negative 4/5 divided by 2, and then you're going to square it. So when you take a fraction and divide it by a fraction, you get negative 4/10 squared, which I'll go ahead and simplify before I actually square this, just so the numbers stay small. It's negative 2/5 squared, which gives you 4/25. So that's my new c value. So I need to add that to both sides of my equation. So x squared minus 4/5 x plus 4/25 is equal to 2/5 plus 4/25. I can go ahead and factor this left side. It's going to be x minus, and then it's going to be the number that we squared. So it's 2/5 squared, and that's going to be equal to, so I have 4/25, and we're adding 2/5 to that. Well, if you multiply the top and bottom both by 5, you get 10/25. So this is going to be 14/25. I can now take the square root of both sides of my equation. You get x minus 2/5 is equal to plus or minus the square root of 14, because 14 is not a perfect square, over 5. I'll add 2/5 to both sides. You get x is equal to 2/5 plus or minus the square root of 14 over 5, which gives you x is equal to 2 plus or minus the square root of 14 over 5. And that is your answer. If you wanted to convert that into a decimal, you would say 2 plus the square root of 14 divided by 5 and 2 minus the square root of 14 divided by 5. So that's a quick rundown on completing the square. We have a assignment over this. If you have questions, just let me know.